Example 1. Given the arithmetic progression 5, 15, 25 and so on, A. Find S6. Now S6 represents the sum of the first 6 terms of this arithmetic progression. So the sum of the first 6 terms is 5 plus 15 plus 25 plus 35 plus 45 plus 55, and that equals 180. Part B, show that S6 minus S5 is equal to T6. So that's the sum of the first 6 terms minus the sum of the first 5 terms of this arithmetic progression. And we need to show that it equals the 6th term of this arithmetic progression. So S5 is equal to 5 plus 15 plus 25 plus 35 plus 45, and that equals 125. Now S6 we've worked out from part A, which is 180. So S6 minus S5 is equal to 180 minus 125, which equals 55, which equals T6 as required. Now it is worth noting that Tn, or the nth term of an AP, is equal to the sum of the first n terms minus the sum of the first n minus 1 terms. And T1 is equal to S1. That is, the sum of, well, the first term, or the only term, which is just the first term, is also equal to T1, which represents the first term as well. And this is a useful starting point when dealing with problems involving sums of arithmetic progressions. Example 2. State the first 5 terms of the sequence of partial sums, S1, S2, S3, S4, S5, given the arithmetic progression 2, 5, 8, and so on. S1 represents the sum of one term of the AP. S2 represents the sum of the first 2 terms. S3 represents the sum of the first 3 terms, and so on. The AP itself, 2, 5, 8, has first term of 2, common difference of 3. Now S1 is just equal to T1. So therefore S1 is equal to 2. It's just the sum of one term. S2 can be found either by S1 plus T2 or just T1 plus T2. So first sum of the first 2 terms. So therefore S2 is equal to 7. Now S3, so the sum of the first 3 terms, can be found by taking S2, which has already been determined, and then adding on the third term. So 7 plus 8 equals 15. So therefore S3 equals 15. Now the next term along in the AP is 11. S4 is equal to S3 plus T4, which is 11. And S3 is the sum of the first 3 terms, so that's been determined already, that's 15, plus 11. Therefore S4 is equal to 26. Now the 5th term along, adding 3 to 11, is 14. So S5 is equal to S4, which has already been determined as 26, adding on 14, and therefore S5 is equal to 40. So therefore, the sequence of partial sums of the AP is 2, 7, 15, 26, and 40. So notice also that this particular sequence is not an arithmetic progression. After all, the common difference, well, there is no common difference, and the terms seem to go up by bigger and bigger amounts each time. So just as a bit of a recap, this is the sum of one term, sum of 2 terms, sum of 3 terms, sum of 4 terms. So these terms are in fact cumulative. Example 3. Write the first 5 terms of the arithmetic progression given S8 equals 92, S9 equals 117, and S10 equals 145. Now S8, S9, and S10 represent partial sums of this arithmetic progression. S8 represents the sum of the first 8 terms, S9 represents the sum of the first 9 terms, and S10 represents the sum of the first 10 terms. Now we can use this rule here, Sn equals Sn minus 1 plus Tn, and we've seen this in a previous example. So the sum of the first n terms can be found by taking the sum of the first n minus 1 terms and then adding on to that Tn, the nth term. Rearranging this formula, we have Tn, so the particular term in this AP, or the nth term, can be found by taking the sum of the first n terms and then subtracting from that the sum of the first n minus 1 terms. So let's find T10, since we have S10 and S9. So T10 is equal to S10 minus S9. T10 is equal to 145 minus 117. So we have T10 is equal to 28. Likewise, and using the same method, we can find T9. T9 is equal to S9 minus S8. T9 is equal to 117 minus 92. Therefore, T9 is equal to 25. So we know that these two terms form an AP. And we also know that this is the 10th term, this is the 9th term. So let's find the common difference. So we can subtract T9 from T10. So D is equal to 28 minus 25. So therefore D equals 3. Common difference of 3 there. Now to find A, the first term. So I'm going to use T10 here. T10 equals 28. Well, no, that's the 10th term. And that's equal to A plus N minus 1D. So 28 is equal to A plus 27. And therefore, A equals 1. So therefore, the first 5 terms of this AP is 1, 4, 7, 10, and 13. Example 4. Given Sn equals n squared, show that this forms an arithmetic progression consisting of the sequence of odd numbers 1, 3, 5, and so on. Now we can apply the rule that Tn is equal to Sn minus 1. That is, the nth term of this arithmetic progression is found by taking the sum of the first n terms and subtracting from that the sum of the first n minus 1 terms. Now in this case, Sn is equal to n squared, and S of n minus 1 is equal to n minus 1 all squared. So expanding this perfect square and then expanding the brackets a second time to take into account this negative, we get Tn is equal to n squared minus n squared plus 2n minus 1. The n squareds will cancel. So we have Tn is equal to 2n minus 1, where n is equal to 1, 2, 3, and so on. Now we can express Tn equals 2n minus 1 in A plus n minus 1D form. And we can see that this represents the AP 1, 3, 5, 7, 9, and so on. In fact, this form here, I've just included that just so you can see that it can be expressed using the A plus n minus 1D form. However, we don't need to express it in this way. We can still use just 2n minus 1. So if we substitute n equals 1 into this Tn formula here, the nth term formula here, 2 times 1 is 2 minus 1 is 1. Substitute n equals 2. 2 times 2 is 4. 4 minus 1 is 3, and so on. Example 5. Evaluate the following sums. Part A, the sum from n equals 4 to 7 of 3n plus 1. And B, the sum from n equals 2 to 6 of negative 2 all to the power of n. Let's have a look at part A. So when n equals 4, 3 times 4 plus 1 is 13. When n equals 5, 3 times 5 plus 1 is 16. When n equals 6, 3 times 6 plus 1 is 19. And when n equals 7, 3 times 7 plus 1 is 22. The sigma notation just means add them up. It's just the sum. So 13 plus 16 plus 19 plus 22 equals 70. Part B, the sum from n equals 2 to 6 of negative 2 all to the power of n. So we'll just form the sequence and just add them up. So negative 2 all squared, so that's when n equals 2. So negative 2 all to the power of 2 plus negative 2 all to the power of 3 plus negative 2 all to the power of 4 plus negative 2 all to the power of 5 plus negative 2 all to the power of 6. So that's what it means from n equals 2 to 6. So 2, 3, 4, 5, and 6. And so all the even powers, of course, will result in positive values, and all the odd powers will result in negative values. So this evaluates to 4 minus 8 plus 16 minus 32 plus 64, which equals 44.